Hello, one and all. You're welcome to this week's Tech Tuesdays webinar on Enterprise Data Catalog 10.5.x architecture. I'm Vrinda, your host for today's session, and we have with us Sugi Narayana, Senior Manager from the Customer Success Technologies team, and Avanish Srivastava, Principal Customer Success Technologist, as the presenters for today's session. Before we start the session, let's go through some housekeeping tips. The webinar is for 1 hour that includes a 15 minutes Q&A. You can post your queries in the Q&A window. Dial-in participants will be muted for the entire session. The session is being recorded and will be available in the Informatica Support YouTube channel and the Success portal, from where you'll also be able to download the slide deck. Please feel free to put in your feedback and suggestions for the session in the post-webinar survey. The Tech Tuesdays webinars are hosted within the Success portal, which is a micro-learning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. Here are a few important links that you can go over later that will help you in your product adoption journey with Informatica. Over to you, Sugi and Avanish. Thank you.
Thank you, Vrinda. Welcome again, everyone, to this webinar on EDC 10.5 architecture. My name is Sugi Narayana, and I'll go ahead and kickstart the session today. Here's the agenda for this webinar. We'll start with an introduction to EDC 10.5, the new tech stack, followed by an architecture deep dive. We'll also go through the scanner process overview and internals, followed by security, high availability, and disaster recovery aspects of the product. We'll also cover the deployment and sizing best practices, followed by Q&A session. Moving on, few call out on the scope side. Enterprise Data Catalog, abbreviated as EDC here. Version 10.5 is considered for this discussion today. The content is not specific to a particular cloud ecosystem like AWS or Azure, but the architectural concepts of EDC will remain the same if you deploy on any of these cloud ecosystems. Enterprise Data Catalog vision. Here is our vision for EDC, and our vision is for Enterprise Data Catalog to be the Google for enterprise data assets. EDC enables business and IT users to unleash the power of their enterprise data assets by providing a unified metadata view that includes both technical and the business context, with user annotations, lineage, relationships, data quality, usage metrics, and many other details. Right? A few screenshots from the product shown. The first one showing the Google-like interface for searching your enterprise data asset. We also have the ability to profile the data to understand the lineage, certification, user rating. So it provides a better understanding of the enterprise data assets and also helps to find out the trusted data in your organization. The entire platform is AI powered and with all these automatic entity discovery, classification for like data domain discovery and stuff like that. And we also provide scanners for the variety of enterprise data sources available in the industry. Some of those items are also listed out here. And we also have advanced scanners that are covering some of the legacy data sources as well. All right, with that, let's deep dive into the EDC 10.5 architecture, which is the main topic for today's discussion. Let's start with the new tech stack used in EDC 10.5. Starting version 10.5, EDC will be using this new Nomad plus MongoDB based architecture. For storage, we'll be using MongoDB and MongoDB grid file system. PostgreSQL will be used for all the similarity, and we are also using Solr. For orchestration and security, we use the Nomad based cluster. For service coordination, we use Zookeeper for all the service coordination. We use native Java for all the scanner jobs and ingestion service that's getting submitted to the Nomad cluster. So let's go a little in depth to see how each of these storage systems are used by the product and what tech stack maps to it in this particular table. For storage, we are using MongoDB, and MongoDB backed by its own grid file system, like I already mentioned. MongoDB will be the main storage for all the metadata assets extracted from data sources. The lineage and relationship derived based on the metadata extracted. And MongoDB is also acting as the staging area for the content scanned, right? And we are also using MongoDB for monitoring as a monitoring store for jobs submitted in the Nomad cluster. And also it maintains the long-term scan content in its grid file system. We use PostgreSQL for all the similarity profiling that helps to infer similar columns from other data sources. Solr is used for index creation that helps with fast search and analytics. Relational DB is used for storing the resource configuration and the data asset analytics. Right? So resource configuration gets stored in the same relational database that you configure for model repository service in the Informatica platform. For workload orchestration and security, we use Nomad, like I already mentioned. And Nomad by itself is the simple and flexible workload orchestrator to deploy and manage containerized as well as non-containerized applications across both on-prem and cloud at scale. So we use that to execute the scanner jobs across the different nodes configured in the Nomad cluster. And of course, like we already talked about Zookeeper, that helps for all these service coordination, and native Java-based scanner jobs are used for execution within the Nomad cluster. Okay, moving on. Let's go through the Enterprise Data Catalog application stack and see how the tech stack that we went through aligns against these different layers. On the storage layer, we already discussed in detail in the previous slide about the usage of many of these tech stack here, MongoDB, MongoDB Grid File System, PostgreSQL, and Solr. And we also discussed that the MRS relational DB is used for the resource configuration. The profiling warehouse database, that's a relational database as well, that acts as the temporary storage for all the profiling results. Right. So moving on to the processing layer. In the processing layer, we have data profiling engine, which is one of the main components. It takes care of profiling the data sources for data discovery, data domain classification, value frequencies, uniqueness, and whatnot. And that's the result which gets stored in the profiling warehouse. We have a Nomad cluster, which we discussed already. For the compute purpose, we use HashiCorp Nomad, and this helps as the workload orchestrator basically to distribute the scanner jobs across the different nodes configured in the Nomad cluster. Right. On the services layer, we have like services internally used and more like a service-oriented architecture. We have search services, lineage services, relationship services, job management services, a scheduler for all the job scheduling and other purposes. So it's all used internally. And we also have plugins for the scanners to be run. And also we have inference analyzers, which is like deriving new facts based on the existing facts, like similar columns and whatnot. We have the data profiler plugin and also a plugin for the ingestion service. And on top of all these things, like we have a rich set of REST API made available, and this REST API can be consumed by third-party application for integrating the catalog assets and contents into their application. And as a matter of fact, the catalog UI and the catalog admin UI that we the provision basically is internally using these REST APIs as well, right? And that forms the complete enterprise data catalog application. Right. So let's deep dive into the EDC services architecture. let me stop up to this one. Some of you who are familiar with the Informatica platform already, you'll be already familiar with these services, whatever we are showing here. For the benefit of everyone, I'll go through these services at a high level. Right. So EDC services by itself, they reside in a central administrative unit called Informatica domain. And the Informatica domain is a collection of nodes and services that follows the standard service-oriented architecture. So here I'm showing like two nodes. One node is the infrastructure node, another one is the profiling node. And within these two nodes, these two nodes are part of the Informatica domain, and the metadata related to the domain is all getting stored in the relational database. So you have the set of relational databases shown here, and it can be Oracle DB2 or any other database supported in our product availability matrix, right? So the domain related metadata gets stored in the domain database. And in the infrastructure server node, you can go for creating the model repository service. You will basically be getting into the admin console and create a model repository service. So model repository service is a service which will basically store all the domain related metadata, data domain related metadata, data domain rules, or all the mapping information. And also it basically stores the resource configuration that you are creating in EDC. So that it stores the MRSDB, which is a relational database again, right? And you will be creating a data integration service, which is the data profiling engine that we talked about in the previous slides too. And this does the heavy duty work in terms of doing all the data discovery to understand the uniqueness and value frequencies and whatever, right? So all these results, the profiling results, get stored in the profiling warehouse. And content management service used for all the managing the reference data, like address reference data and whatnot, which is used the data quality mappings within executed by the data integration service. Right. So you also have analyst service, which is basically hosting the business glossaries. And this business glossary in turn can be scanned into the enterprise data catalog application, and it can be tied to the technical assets to get better business context on those technical assets. So, and these business glossary also gets into the MRS database for storage. So up to this is the standard Informatica data quality platform architecture. But let's get into the specific services for EDC application, which is the Enterprise Data Catalog service application. Another one is the Informatica cluster service. So you will be creating both these services in the same Informatica admin console itself. Right? So when the Informatica cluster service is started, and this goes in for deploying and managing the MongoDB and Nomad based cluster, which is called the Informatica cluster here. So that cluster, it will be deploying and it will start managing all the services in that cluster also. Right. And any required binaries for MongoDB or Nomad, it's all bundled in the Informatica installer itself, so you don't have to go anywhere for downloading or whatnot, right? So you'll see all the services that we talked about, be it the MongoDB or the Nomad service, like the Solar, PostgreSQL for similarity, and Zookeeper for all the service configuration maintenance. Everything is deployed as part of the Informatica cluster that gets created, right? And whenever you create the enterprise data catalog service, depends on the Informatica cluster service. Once the Informatica cluster service is up and running, you can start up the enterprise data catalog service, and that creates two user interfaces, one for catalog administrator, another one for enterprise data catalog, which is the Google-like UI, which we were talking about for searching all the metadata assets that's stored in your cluster. Right. So within the catalog administrator, you will be creating the resource for scanning a specific data source. And when you run that, it goes in for kicking off this scanner jobs, which is the native Nomad jobs that run in the Nomad cluster, and they go for pulling the metadata from the data source, and they ingest the metadata assets into the MongoDB, and all the indexing details are stored in Solr, and any similarity inferences that we have is all getting into the PostgreSQL. So this is the architecture which helps to scan the wide variety of industry, the data sources available in the industry, be it the enterprise data warehouse, any relational database, or any business intelligence applications, or like data integration applications, file systems. So everything is supported for scanning through the enterprise data catalog application. And we also have the option to push down the profiling logic to a Hadoop cluster. And maybe you want to profile some data on HDFS, or like you want to push down the actual profiling logic to the Hadoop cluster for a distributed processing, and that's possible too, and we support that actually, and you can see the Spark jobs are getting submitted for that purpose, right? And you also have the option to push down that same logic into the Databricks as well. So if you have a Databricks table that needs to be profiled and whatnot, so all those things are possible with this particular architecture, right? So that covers the EDC 10.5 services architecture. Let's move on. And this slide specifically goes into the details of the Informatica cluster service architecture. So like I mentioned, the Informatica cluster service is the one which deploys and manages the Nomad and MongoDB based cluster in the previous slide. So if you see the Informatica cluster service, this is running in the Informatica server. And this has been configured with a 3-node Nomad and MongoDB cluster, right? So node 1 acts as the gateway node as well as data and processing node. So wherever MongoDB is running, it's called the data nodes. It's like a data node, right? Because MongoDB stores the data assets, and wherever the Nomad clients are running, it's also a processing node. It's called a processing node where the scanner jobs can be run, and the job can extract the metadata from the data sources. And the gateway node is the node which basically interacts with the Informatica server to basically deploy the binaries and create the Nomad cluster, right? And that goes through the SSH way with the gateway user and logs into the node 1. And the rest of them all are through the Nomad APIs for any scanner job execution. And you'll see node 1 is connected to node 2 and node 3. They're all in the cluster, and they all communicate internally through SSH and the Nomad APIs. Right in this architecture, you can see node 1 is configured as the gateway node as well as data and processing nodes, which means the Informatica cluster service running on the Informatica server is contacting this gateway node for deploying this Nomad and MongoDB cluster. Because it's a data node, here MongoDB is also running, that's why it's a data node. And Nomad clients are also deployed in this one, so it's also a processing node, which means like a scanner job can be running on this node 1 as well. And Zookeeper and Solr runs on all these nodes, whatever is configured in the cluster, and taking care of Solr for all the indexing part, and Zookeeper, which maintains the distributed configuration and service coordination. So here node 2, this is only a data and processing node. Again, like MongoDB is running here, that's why it's a data node, as well as a processing node, because a Nomad client is also deployed in this one, right? Same is the case with node 3. So this is a typical 3-node architecture where the MongoDB and Nomad cluster gets deployed and be part of the Informatica cluster service. This slide shows the Informatica cluster service architecture in a more simplified way. What you see on the left side of this orange line is the Informatica Cluster Service, ICS here, and the catalog service deployed as part of the Informatica domain. And to the right side, you see a 3-node and Nomad-based compute cluster created by the Informatica Cluster Service. In this case, node 1 in the cluster is configured as the gateway node, and node 1 is also a data and processing node. Node 2 and node 3 are also configured as a data and processing node. So as I already mentioned, the data nodes are where MongoDB is configured to run. Processing nodes are where the Nomad clients run, right? So you can have a node configured as both data as well as a processing node, which is the case for node 2 and node 3, and as well as for node 1. Node 1 is also a gateway node. Right? So you can see Zookeeper, Solar, they're all running on all nodes. PostgreSQL runs on the gateway node, and as mentioned earlier, PostgreSQL stores the similarity results. So what happens when a scanner is run, right? So when a scanner is run from the catalog service admin UI, it contacts the Informatica Cluster Service using the REST API that's exposed. And the Informatica Cluster Service contacts the Nomad-based compute cluster, and the scanner job gets executed in one of the processing nodes. Like I mentioned already, a processing node is a node where Nomad client runs. In this case, the scanner job runs on node 2, where the Nomad client is running. Okay, so now let's go through the scanner execution overview. The scanner run by itself is divided into multiple Nomad jobs. And each of these Nomad batch job is responsible for different stages of this particular scanner execution. So we have highlighted the 4 stages here. First stage is the scan or metadata load. It basically, the job launches a scanner to scan source system and produce the output basically in the exchange documents format to the file system. Basically, it scans the source system and creates the extract format output to the file system. And there's a stage job which basically runs in parallel with the scan task. It monitors this file system, reads that exchange documents and transforms them and uploads them to the warehouse as collections, like extract collections, right? And these corrections will be worked on by the resolve job, which basically works on all the stage documents for a single resource and helps to resolve any parameters that values that needs to be substituted, and any reference object that needs to be created for missing connections. And also it takes care of any delta detection here, right, at this stage. Once the resolve job is done, the publish job takes care of publishing all these search attributes, indexes, lineage into the respective storage in that metadata warehouse. Right, so this is at the high level. And now if we get into the actual execution flow in the architecture, so first one is like the scanner framework launches an application on Nomad. So that's where you see that Nomad application gets spawned in the info cluster, which is the Nomad MongoDB based cluster. And this application basically reads that scanner related configuration from MRS. So that's where this line comes into play. Right, and once the scanner application spawns a scanner agent, it basically extracts the metadata directly from the source. That's where this dotted line comes into play, or through EDC Security agent. Okay. And in case of any relational source, the scanner application sends that request to data integration service for any data profiling job to be run, and that profiling results are stored in the profiling warehouse. And the fourth step, the scanner process reads that profiling result from that profiling warehouse. And once all scanner stages are completed, metadata results are staged into MongoDB commit store to be processed by the ingestion service. Right. The ingestion service, which is again native Nomad Java-based job, processes the metadata and it ingests the graph details into the graph database, which is our MongoDB, and any indexes into the Solr cloud. So when the similarity discovery scanner runs, it reads the metadata from the catalog and writes into the commit store to be processed by the ingestion service again, and this cycle continues. Right. So this covers the scanner process internals, and we are also completing the EDC architecture deep dive with this slide. I will stop here and invite Avanish to take us through high availability, disaster recovery, and rest of the topics for this session. Thank you, everyone.
Thank you, Sugi. Hi, everyone. This is Avnish, and in this section of the presentation, we will start with the EDC's high availability and disaster recovery approaches. So let's jump right into it. So before we, begin talking about high availability and disaster recovery, it is important to understand that what they mean and how they are different, because we often, get confused between the two. So as this slide shows, right, high availability is more, aimed to avoid a single point of failure. It is normally applicable on a single site installation, and it is more, faster turnaround with high availability. Automatic recovery is and automatic restarts, things like that, are part of high availability. And automatic failover in case of hardware failover, application failover, service failover. So these are the scenarios which are answered by high availability. On the other hand, disaster recovery is to ensure that the uninterrupted operation goes on. It doesn't have to be active sort of set up with disaster recovery. It might take some time to bring up the disaster recovery side, but the more important thing is that you do not lose all the content you have built over the years. It is generally applicable in case of a natural calamity like earthquake or hurricane or something like that. And of course, the business continuity is a prime example of that. And disaster recovery is configured across multiple sites, different geographies. So you wouldn't have your primary data center and disaster recovery data center next to each other. They will be at least, if not countries apart, then I would say miles apart. Now, with that, let's jump into the EDC services high availability. So this slide here, we show the key application services in Informatica platform, which constitute the EDC's experience. So model repository service, data integration service, catalog service, Informatica cluster service. And Sugi has already talked about these services in detail, I know. So you by now understand the functions of these. But they are all by default or out of the box configurable to run on a primary and backup node configuration. And of course, this is only applicable, this high availability is only applicable if you have more than one node. And we do recommend that there should be at least 2 nodes on platform side to host to act as infrastructure and profiling nodes. So basically, if you have 2 nodes, you have to configure your services to run on primary and backup nodes so that inbuilt HA is available on the service level. And of course, if you have the HA enabled, the services will fail over to the backup node if the primary node goes down. Now, on the cluster side, the high availability is, we have already talked about the cluster architecture, right? That how you have to have at least 3 nodes to set up a highly available cluster, and what are different components of cluster, the EDC cluster. So let's run through them one by one. So Zookeeper is going to be deployed on all cluster nodes. So if one of the nodes goes down, your Zookeeper is there. Solar, which is used for the search indexing and all those things, that is deployed on all cluster nodes. MongoDB and Nomad. So MongoDB is your, like metadata asset repository, and that can be deployed on multiple nodes and or all nodes. So in case of a 3-node cluster, which is most common as we see it, you will have MongoDB on all the nodes, and that makes it highly available. Same goes for Nomad. It can be deployed on multiple nodes or all nodes, and this is something. This configuration is something you can choose in Informatica Admin Console. I will show some screenshot of that in a moment. But to understand the high availability part of it, we should know that, this is something we can configure on more than one node, and that's what makes it highly available. PostgreSQL DB, which is your which is the similarity storage, which is that is deployed on single node as of now. So, which means that out of the box, it is not highly available. But we have a roadmap item to externalize this PostgreSQL DB, which means that this whole storage can be managed in a customer's own PostgreSQL database, and that can be highly available, which can remove this limitation. So that's all the highly available components on the cluster side. Now let's and for highly available, I mean, of course, we are not setting up a backup node or something. It is all based on like 3-node or more setup. You will get that high availability concepts in place. Now let's look at a disaster recovery scenario. So I have this one slide, to show the disaster recovery architecture overview. This is one of the approach. There may be some other ways as well, but I believe this is something which can be preferred over the other approaches. So here we see that there's a primary data center and a data center at the DR site, which is disaster recovery site. And we have one EDC environment on the left side, which is the active one, and another EDC replica environment, which is on the right side, which is the non-active EDC environment. And if you notice, the infrastructure and metadata profiling node on each side are part of the same Informatica domain. So basically, you can have one Informatica domain and you can have 4 nodes under it. 2 will be on and act as the infrastructure and metadata processing node. And the other 2, which is on DR side, they don't have to be up and running. Cluster nodes will be, they will be on primary side as well as on the backup side as well. And repository databases or the file systems, they all need to be, replicated. And all these components, there has to be certain backups and things to be, some external processes, to take these backups and make it available, keep it restored on the DR side. And metadata sources, they need to be, they have their own, I believe, primary and backup thing. Whatever metadata is in EDC, it is ingested in EDC. That will, of course, be available through EDC catalogs, disaster recovery. But for your source systems, they should also be available to be scanned. But I believe in a real life scenario, if EDC is to be shifted to a DR site, you don't really need the metadata sources to be available on the DR side, because you may not need to run scans at that point. But at least all the metadata, all the content of the catalog should be able to be restored in the DR site and should be searchable. And with that, I should also mention that all your user authentication processes like LDAP and those things, since it is all part of the same Informatica domain, that will also be intact. So if you see these 3 steps, basically this is on a higher level. But perform the regular backups and copy the backup files to the DR environment. EDC has a hot backup feature, which means you don't have to take EDC down or something or impact users so much for taking a backup of the catalog. And this was something we introduced very recently. So in 10.5, it's of course available to be used. And at DR time, when the disaster recovery testing or real disaster recovery is happening, you have to start the services on the backup node and restore the service backups. And for all these things, you can create a script as well. Informatica provides command line utilities to do a lot of automation here. And once you ensure that all dependent services and other applications are restored in DR site, then the DR site can be used for testing purpose or the actual usage purpose based on what you're trying to do. So that's a high level disaster recovery, and I would mention that there would be some downtime in a disaster recovery. It wouldn't be an immediate turnaround for DR site, and I believe it will be expected in a genuine DR scenario. Since it is a metadata catalog, it may be okay to wait for some time, but yeah, a lot of these processes can be improved if you script it out, if you test it often. So that's something we would recommend. But yeah, there are many external components within Informatica catalog because there are source systems, there are databases, there are files. So all your backups and things needs to be taken carefully and moved over, based on the chosen sequence you want. Now let's talk about EDC security considerations. So the things which we have to keep in mind and how EDC takes care of all those security challenges based on the data and metadata which is kept in EDC. So let me just jump into our first slide here on how to make EDC secured. So we have, put the EDC security in 3 different perspectives here. First is communication level. So how you can, secure the communication in EDC. So if you EDC is, of course, the catalog is to be consumed by a larger community of users. So a lot of people will be logging into EDC as a catalog user or as an admin. So EDC does allow the endpoint SSL encryption with a certificate of your internal certificate, or you can use Informatica's default certificate. But yeah, we recommend using your own certificate for better security around that. And EDC does support, SSL for all the internal communication as well. So the services which are talking to each other internally, the application services, they do go over a secured SSL, and these things are something which is to be taken care while doing the installation of the product. This is all available as an option, but we recommend customers to choose these options to create a secure application. Now the second thing is storage level access control. So as you can see, we have listed out that how the critical pieces of information which goes into EDC, like value frequencies or the passwords in the scanner configuration, they are all encrypted using the site key or the AES-256 encryption mechanism. So yeah, that storage level access control is in place for EDC. The third aspect of this is the applications level security. So how we can ensure that people are getting to see only what they are meant to see. It's like putting privileges and permissions, creating reusable roles, so that you can easily onboard users. You don't have to really run every user through a series of process before they can start using the tool. But at the same time, through these roles, these permissions, these privileges combination, you can also ensure that people are only getting to see what they're entitled to, and all of that is taken care as through the application level privileges and permission control. So we will look into each of these aspects one by one. So as I talked about, the first one is communication level or the endpoint level. So this slide you have, I guess, to some extent you have seen how the scanning process and all those things work. But we are not showing the step-by-step scanning process here. We are highlighting like what all ports are used. On the left side, you can see that what are the different application services on Informatica perspective, like domain core service, admin console, DIS application, which is used for profiling, CMS application, which is all the reference data, ICS, which is your cluster service, and EDC application like EDC admin UI, EDC catalog UI, or even the REST API calls, how they all are routed through Informatica catalog service or Informatica server. And on the second half of the page, you see the Nomad UI and Solar UI. How they, I mean, these two UIs are not something you will be using as a customer, but if your administrators are willing to open Nomad or Solar UI, they can also open those UIs to, and those are the ports which will be used, and that is encryption, like server key store location will be used to encrypt those communications. Now, if we come to the middle section of this document, we see how Informatica cluster service, catalog service, model repository, content management service, how they are all interacting through secure protocols, and how that communication is encrypted end-to-end. And on the far right side are our source systems. So this is where, as I mentioned, that source system, one of the key things is, of course, we keep the credentials, so they need to be secured, and they are secured using our encryption mechanism at the source level. When we bring in the data, like the value frequencies and everything within catalog, they are also secured using AES-256 encryption mechanism, as I mentioned. So that's basically a high-level overview of, a further deep dive into the secure endpoints and secure communication between EDC services, and how different SSL certificates are working together with specified ports to ensure a secure application. Now let's look at the mutual TLS architecture, the SSL mutual SSL architecture, which we started offering starting 10.5 series. So as you see, right, I mean, in this slide here, we have MongoDB, Solar, and PostgreSQL. These are the three places where a lot of metadata, indexes, or value frequencies are kept. And when catalog service, which resides in your Informatica domain, or the Nomad server, which is part of the cluster itself, when they interact with these components, they use the mutual TLS architecture, which means that they present their certificate, which gets validated, and then they get the certificate from the receiving end. And so basically both ends validate their certificate to ensure that a successful communication is in place. So that's why we call it mutual TLS. It was not there in our previous, like in 10.4 series, but we only started doing it in 10.5 to add additional security into the application. Now, the third one is, of course, the application level security privileges. So as we mentioned, right, Informatica provides a lot of privileges and permissions, which can be configured to create groups or roles accordingly. And in this screenshot, we do see that, this is Informatica Admin Console, Informatica Platforms Admin Console. And you can see that how a specific group called retail is having privileges on catalog service, like it can use REST API, it can log into catalog, it can view data, the metadata, and it can view data, view sensitive data. So, excuse me. So these are all the privileges available to this user. But using Informatica as Admin Console, you can create groups and roles and onboard users more easily. Not to mention that Informatica has always been providing connectivity to LDAP or Active Directory systems. So if we have defined a role which is tagged to these privileges and permissions, then onboarding users into Informatica application becomes easy through these privileges and permissions. Now, the next set of permissions is the next set of security, I would say, is at the catalog administrator level. So we just looked at Informatica admin console where we use privilege and permission, but within the catalog administrator, which is just the administrator UI for EDC application, you can choose that, which use a specific group or a user, what all metadata can they see. So generally, you can expose all the metadata as well to every user, but then if it is more LOB based and you don't want one person from an LOB to see the metadata from another LOB, then yeah, you can use resource level access control as well. That's what catalog administrator allows us to do. And in this example, I've shown a screenshot of the same, where I'm using the same retail group and I'm showing what all resource it is having access to. For the relational systems, we can be a bit more granular, which means we can choose if the person can see tables, views, or synonyms within the resource. And the type of accesses which a person has is like read only or read and write or metadata and data read or all permissions. So they are self-explanatory, I believe. Read means only read, write means they can edit content as well. They can read metadata as well as data, or you could just choose a superset of all, which is all permissions. Now, this is just an idea to share here that when you are creating, as I mentioned, right, user onboarding into the data catalog is a very key thing. So it is recommended to come up with predefined roles or predefined groups based on the activities which users will do. Like somebody would be an administrator, which is like a super user. Somebody would be a steward, which will be more active techno-functional role in EDC catalog to edit content, to curate content, to maintain the definition, to remove false positives of data discovery. Could be more things than that, and then there are data analysts, which are just the consumer, maybe read-only sort of personas. There could be some privileged analysts which don't just read metadata, but data as well. So these are some out-of-the-box things which you can configure to make the user onboarding easy. With this, let's jump to the next section of our presentation, which is sizing and deployment. So we have talked about the architecture, the scanner process flow, the security, and I believe the HA and DR, high availability disaster recovery as well. Let's look into how EDC sizing and deployment works, So this is the EDC sizing guideline. And we also have this published, not exactly this slide, but yeah, we have the sizing information published through Informatica EDC documentation as well. I have put that link in one of the slide here today as well. But let's look at how we do the EDC sizing, right? So on the far left side, you can see that, we have environment size, which is small, medium, large, or extra large. And the way we categorize this is like based on number of concurrent users. Like is it gonna be 20 concurrent user and 200 total user, or will it gonna be a medium size with 50 concurrent user and 500 total user? So that's one criteria. And then the number of objects, which means the assets in the data catalog. So up to 2 million, it is small. Up to 20 million. From 2 to 20, it is medium, then to 50, and then to, and we have got large and extra large category as well. Like up to 50, it is large. Beyond that, it is extra large. And then you will see that, yeah, these are the three prime, sections: infrastructure node, metadata processing node, and infra cluster service. So infrastructure node is where, you will house your catalog service, cluster service, all your domain components like model repository services and all domain services too. And we have shown the CPU, which we expect to have on that server, the RAM and the storage. And this changes across, right? I mean, when you move up the sizing. For metadata processing, for discovery purpose, when we say discovery, we mean the profiling and data domain discovery or unique key discovery. So for that requirement, for small, you can see it is 8 and 16. For medium, it is 32 to 64. And then, of course, this storage and RAM and CPU requirement keeps changing. Now, if you are using advanced scanner as well, so advanced scanner is also something we have to scope for while coming up with a EDC server sizing. So 4 CPU, 12 GB RAM, and 50 GB disk is something we have to keep for advanced scanner as well. And based on the number of scanner, this might scale up. But let's suppose that if you're not going to be running advanced scanner every now and then, and it's just one advanced scanner or 1 to 2, then this size would suffice. Now let's talk about the bigger component here, the Informatica cluster service. So the Informatica cluster service for small, which is up to 2 million, you could do with one node for to deploy all MongoDB, Nomad, and all the other components on just one cluster node, which could be 8 CPU, 34 GB RAM, and up to 120 GB disk. Actually, 120 GB disk. And there is something called a similarity store as well. So there is a PostgreSQL DB, which we saw in the architecture, that keeps all the similarity stores. There is a similarity store. So we recommend to have a dedicated node for that similarity store, which means there will be 2 nodes in the cluster in this small setup. One for cluster components like data, compute node like MongoDB, Nomad, and everything, and one for only PostgreSQL DB. Now we have often seen that customer wants to just keep one node and horizontally scale the cluster node to accommodate the same similarity as well, or they may say that, yeah, we don't have a lot of similarity usage right now, so we just don't want to have a dedicated node to it. So that is fine. It can be done as long as it's informed decision. So you could club the two into one node here. Now for medium, I just want to highlight, this is more common, the medium category. So you would see 3 node, which means 24 CPU overall. So that means 8 CPU on each node. So 8 times 3 is 24. 24 GB, 72 GB RAM in total. That means 24 on each. And this is the minimum. If you have more memory available, it is fine. But yeah, that's something we recommend for optimum performance, that you have to have at least this much. And 2 TB of disk on this one. Now you can see that the similarity store, we have just grown up in disk, but yeah, 816 is still required. And the same logic applies here as well. If you want to have similarity store on the within one of these 3 nodes, you can horizontally scale the gateway node and keep the PostgreSQL there. If you do not plan to use it so much, or if you want to just not maintain more than 3 nodes, let's say. So that's high level on the sizing side, how you would be deploying EDC across all these servers. And the next slide is basically showing us a reference recommendation, like how a common EDC deployment would be looking like. This is more of a medium category, and you can see we have node 1, node 2, node 3 here. and we have got we are also displaying what roles are they playing. So the node 1 here is your gateway node. It's also acting as the data node as well as the processing node. So data node means if it has mostly if it has MongoDB on it. Processing node means if it has Nomad on it, right? So, and of course, Zookeeper and Solar is also running on the gateway node. It is running on all the nodes basically. So the node 1 is your gateway node. Node 2 is your node 2 is your data node as well as processing node. Node 3 is also your data node as well as processing node. And node 4 is also shown here. I've shown it with a little highlight behind it because that is the similarity node. That is where the PostgreSQL needs to be deployed. But as I mentioned, if we need to deploy the PostgreSQL on the gateway node, then we can do that as well if we are ready to horizontally scale and if our sizing and requirement permits for this. So you could see that how the PostgreSQL moved from being on a dedicated node to the node 1 here. So this is a quick slide to show, how your EDC sample platform architecture, how that can be documented when you're done with your EDC installation. So this slide is actually just a screenshot from a video document, which can be, used to document your EDC environment. So here you can see that we are calling out Informatica platform nodes, which is the infrastructure node and profiling node. We are showing what services run on which nodes, and there is a section to specify the OS, cores, RAM, and storage for these. Same goes for cluster nodes. You can be more specific here and say which node is your gateway node, which is your data processing node as well here, and fill in more details on OS, codes, and RAM storage. For repository and profiling database, if you have more details on the database server name, and let me also reiterate that in this place, instead of infrastructure node or along with infrastructure node or profiling node, you can also mention the name, like the actual host name, because it's a internal facing document. It's going to be, so you can be more specific about what is the node name, like the host name and everything. And the purpose of this document is to act as a one-pager for someone to understand the EDC environment from a technical or administrative perspective. So with this, I will go a step further into EDC, cluster service deployment. So let me jump to the next slide here. This is a screenshot, from Informatica's admin console, where if you're creating the Informatica cluster service in Informatica 10.5 series version, you'll see that this is the option you'll be presented with, like which is your gateway host, the first one, as we talked about already, right? Gateway host is the gateway to the cluster. Then data node and processing node. So data node is mostly where MongoDB info is deployed. Processing node is where your Nomad is going to be deployed. And as we mentioned, Solar and Zookeeper will be running on all nodes. So this implementation shows a medium sort of implementation, and it also shows that all three nodes are acting as data and processing both, and one of the node is the chosen one, who will be your gateway host. And there is a cluster custom directory for keeping all the data. There is a shared file system, which is accessible from all three nodes, and enabling advanced configuration is a checkbox, and when you do that, you will be able to be more specific on telling the Informatica cluster service that where your data nodes and processing nodes are. So let's take a quick look at that. How will that be like? So if you enable the advanced configuration, then there are other sections in the Informatica cluster service page in the admin console, where you can go and specify like which is your Nomad server host, which is your MongoDB host. And this would be in general, like maybe if you're doing a 6-node configuration, like let's say an extra large sort of setup, And there you want to have 3 node dedicated to Nomad for just running the scanner, 3 node dedicated to MongoDB to keeping all the metadata. And that's not very likely that someone will begin with that kind of sizing, but yeah, it can be applicable, of course. So when we have to do those sort of specifications in the deployment, that's where enabling advanced configuration and then going and specifying those details will be needed. And some of the things as the working directory, the server working directory, or the client working directory in case of Nomad. So this actually shows where the Nomad server data will be, where the Nomad client data will be. Every processing node will have both of these components running. And same goes for MongoDB, MongoDB log directory, MongoDB data directory. So these are basically just the service components which you specify. And of course, when you refer to Informatica help documentation, which is available through our docs.informatica.com, you will see all these specific details and the description of these options. So with this, I've jumped to this slide, which is references. So for those of for customers who are still upgrading, of course, we are at the end point of the Informatica 10.5 support. But yeah, there is an upgrade planner which has been there since quite some time now. And then we have also mentioned here the performance tuning guidance sizing that should be referred for a lot of critical pieces, like how you are sizing your EDC catalog, especially data asset analytics. A lot of people do not size that properly. So this has a lot of good detail, the 10.5 performance tuning guidance sizing. 10.5 documentation set, definitely look at that. This is pretty much everything under EDC. Performance tuning and sizing for data asset analytics, I have put the link specifically for that because a lot of time we see that EDC struggles because people have not sized the data asset analytics properly. Same goes for profiling, same goes for EDC sizing. And there is a specific mention of how to configure EDC external CA certificate configurations and everything for securing the application. So this knowledge base article is something you can refer, and this slide will be available to you. So feel free to refer to these content whenever you need something. And with that, we are jumping to the Q&A section. So please feel free to type in your questions, and thanks a lot for listening to this webinar. Thank you.
Please post them in the Q&A box if you have any questions. Avanish will answer your questions. Avanish?
Thank you. Thank you, Vrinda. Hi, everyone. Thank you, Sridhar, and I see some good comments for the session. Are there any other questions? Let me see if I think there's one question from Tamil. If gateway node have advanced scanner, PostgreSQL, then data and processing node, then on the gateway node overload. Okay, so advanced scanner will not be on gateway node. Advanced scanner will be on one of the two of your Informatica application node. And PostgreSQL, yeah, if you put the PostgreSQL on the gateway node, you're right. You will have to vertically scale up, if you're planning to use a lot of similarity. So instead of having 888 CPU on all three, you could do a 16 CPU on the gateway node and 88 on the other two. But like I said, we do recommend that you create a separate node for similarity and put the PostgreSQL there. But then a lot of EDC customers from 10.4 they all had 3 nodes. And that's where, if you're not using similarity heavy, or if you can vertically scale up, then definitely, you could still manage with 3 nodes for all of these components. And I guess there is a question from Ray from Ohio Health. Will EDC support for HA for advanced scanner in future release? That's something, yeah, we have to actually check internally. I don't know from the current roadmap for this one, but yeah, please, I guess, yeah, we could, you can reach out to your CSM, I know that you have access to, so we can check internally on the roadmap item, but yeah, at that moment, we do not know of that component being achieved. The slide deck will be available to download, yeah, I guess, soon after this session. I guess Vinda will post it. Why
Yeah,
similarity is
by
filling the
tomorrow
space
you should
only
be
on.
able to download.
Thank you, Vinda.
Please go ahead, Avanish.
Why similarity is filling the space only on gateway node and not on other nodes is the question, because all the data of value frequencies and everything will only be in the PostgreSQL database. It will not be on the other nodes. It will not be in the MongoDB. Yeah, I think there is a question on from Anupreet. Thank you for the webinar, but where can you find user manuals or detailed videos as to show how business units can leverage Informatica Axon? So I would recommend going to Informatica's success portal. There are a lot of bite-sized videos there on how to use Axon. There are a lot of YouTube videos as well, but yeah, Informatica's success portal is a place where you can find a lot of relevant content, and then based on your operational playbook on what your business users are planning to do in Axon, you can create. But we have also seen customers that you can also create like your own videos for those little features and then publish it on your SharePoint so that your business could refer to those. So maybe first check on Informatica success portal, and any gaps you can fill through by creating small videos with like a how to sort of for your business users, and just publish it out on the SharePoint. The log4j, I guess, yeah, the next version in 10.5.2, which is, I guess, coming in few weeks, that will be addressed in that one, in that version. I believe it is coming in sometime in April, in the last week, most likely, but yes, that's when you'll have it. Analyst service and content management service, that's a question from Videng. So when that will be supported? So content management service, yeah, I mean, it is not supported for high availability. You can do some service federation. You can create CMS on more than one node, but yeah, it is not high available by itself. And same goes for analyst service. We do not have any, immediate plan to, configure the inbuilt HA for these two, but I guess there was another question on this, so yeah, we may have to just check internally from the R&D team to confirm you, but there's nothing on the cards right now, from my knowledge. But please raise an interlock, and we will check internally to get you a more concrete update. I believe we answered the log4j thing question from Pradeep, so I'll mark that as answered. I should do that as well. Yeah. Can you explain how Redshift profiling works in the new architecture? We have noticed some large limiting the samples to 100, and the schemas contain only a few tables. This is a thing to server downtime errors sometimes. Yeah, I think if you are doing, depending on the sampling also, generally, I mean, depending on the sampling, it matters, like if you're doing random sampling, then it needs to bring all data. But I believe, yeah, in the prior versions, when I tried with the customer, we were using all the data was being brought in on Informatica server, and then the samples were being taken. So the latest version, I guess, yeah, that needs to be checked for if we could, like just do a query on Redshift side and only bring in the sample amount of data, but it depends on what kind of sampling also you're doing. So if it is random sampling, it has to bring up definitely all the data. But if you're doing first or last, I believe there should be a way to bring in only the data which is specified by sampling. But yeah, this issue was there, so I may have to check again if we have resolved this in the 10.1. The last time I checked, it was on the cards to be addressed. But yeah. Thiru, if you know of anything on the Redshift sampling thing, please feel free to chip in. How do we ensure HA for cluster setup? Should we configure to gateway node? So yeah, gateway node has to be, the HA is there for, like jobs, if the jobs are running and then a node goes down. But yeah, if your gateway node goes down, then you cannot bring it back up, like again, let's say if it is down at the time of start. So that is a limitation on the gateway node side. If you want to create, configure any other node as gateway node, that has to be set up in the cluster survey. So it will be a custom solution if you want to do that. But I guess gateway node is somewhat a limitation on the, on the high availability side. If you have to configure two gateway nodes, you'll have to go to cluster service and specify the node and then bring it back up. It can be done, but then yeah, let's say if your node is down and it is just going to stay there for like that, you can come back to cluster service and change the configuration and bring things up again.
Thank you, Avanish. I think we have tried answering almost all the questions that came in. If we have failed to answer any of the questions, we will get back to you right after the session. Unfortunately, we are on top of the hour and we might have to end this session. Thanks everyone for joining, and thanks Sugi and Avanish for this wonderful session. See you on our next Tech Tuesday. Bye.
Thank you, everyone. Thanks, Vrinda. Thank you a lot. Bye.
Thank you.